Okay, so our final example here, recapping trigonometry in right angle triangles. So this particular question asks us to find an unknown angle, this particular case, that is correct to the nearest minute. Okay? So it's going to follow a pretty similar process to when we're finding an unknown side in a triangle using trig. Alright, we're still going to be relying on our SOHCAHTOA, okay, because we can see that it is a right angle triangle, except in this particular case, we're trying to find this angle here, theta. Right, so just like every single other time that we've worked with this, we want to look at the angle and the sides and their relation to each other. If we start with theta, we'll notice 8.5 meters is opposite theta. And we'll notice that if we go from theta again, 11.2 is actually adjacent. It is next to theta. Alright, so the only ratio from SOHCAHTOA that has opposite and adjacent is this one over here. Tan of theta is equal to opposite over adjacent. So we're going to use this now to fill in some information. Okay, so first off, tan of, unlike other questions, this theta isn't going to change. This is our unknown and it's what we're trying to find in this particular occasion. Okay, now opposite is 8.5 meters. We can tell that from the triangle over our adjacent, which is 11.2. Okay, so what we need to do now is we need to find a way of getting this theta by itself. Now, I won't fully go into the steps, the explanation to justify this next step just yet. Okay, I'll do that another time. But remember when we were dividing and multiplying equations, we always did the opposite, the inverse. Okay, so our next step should be when writing out our solution to have theta is equal to tan with a little negative 1 above it over 8.5 over 11.2. Okay, so now what we need to be careful about here is this negative 1. Okay, you can see this negative 1. Let me just bring this up here for you to actually see this. Is actually not a power. So when we write tan negative 1, sine negative 1, and cos negative 1, what this is actually saying the inverse. Okay? They're not actually powers. So this negative 1 is not a power. If you enter it in on your calculator, your answer will come out incorrect because it's not a power. It's just a notation. It's what was decided a long time ago for us to write in when we're writing out our solution. So just be careful of that, as it's very easy to make a mistake. Alright, so how do we actually do this using the calculator? Well, if I bring my calculator over here, okay, and I'll just make sure that I don't cover this whole thing, you'll notice here that I have a D at the top of the screen, and you need to make sure on all of your trigonometry questions that you're doing, you make sure that this has a D for the moment, okay, it stands for degrees, okay, otherwise you're going to get the incorrect answers. Okay, now to enter this in, we press Shift, then tan, okay, because we're working with tan, you'll notice that we get this little negative 1 just above the tan that we're working with. Just like normal, we enter in our values that we see over here, and we close it off. Now it's very important that you press Shift to begin with. If we press equals, we end up with our answer being 37.1959 ... And this stands for degrees. However, if I just bring this back down again, our original question said to the nearest minute. So, what we need to be careful of here, okay, is that we need to convert this into degrees, minutes and seconds, which can be done just by pressing this button. So, let's bring this back up so you can see. So, theta is equal to 37 degrees, 11 minutes, and 45.25 seconds. Okay? So, when we're working with degrees, minutes, and seconds, it's just like rounding. This here is our degrees, our minutes, our seconds. Because this is past the halfway point of 30 or above, so 30 or above, we round up our minutes to the nearest minute. So our answer is going to be theta is equal to 37 degrees and 12 minutes. And that is our answer. Okay? I hope that helped.